Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Mohamad Naufal Nursyabana from IPSE 2018, and today we're going to talk about enzyme. So before we jump in our topic today, I have a question for you guys. What on earth is enzyme? It's okay, take your time, I'll be waiting. Now I'm just kidding with you guys. That's why I'm here. I'm going to explain it so you guys will know what on earth is enzyme. Okay, so to answer that question, we're going to talk about enzyme definition and characteristic first. Okay, so what on earth is enzyme? Enzymes are proteins that control the rate of reaction in living things. So for a reference, the chemical reaction in the living things, it took lots, quite sometimes. But I mean quite some time. It takes so long for our body. So when that reaction finished, our body couldn't handle it anymore. And eventually our body will give up and will die. So that's the part where enzyme come in to save us. The enzyme lower the time needed for a reaction to finish so it will support lives. And the next is enzyme is a catalyst. A catalyst. That's a strange word. What is a catalyst? Catalyst is a thing that speed up reaction without being consumed in a process. So since an enzyme is a catalyst, that's mean when enzyme help a reaction, that enzyme will not vanish or consume when that reaction finish. That same enzyme also will help that same reaction again when it's come. Okay, so before we go on, I have a graph here to show you guys. So this is the point of the amounts of activation energy needed for a reaction to happen without the help of an enzyme. And this is the activation energy needed for a reaction with the help of an enzyme. Notice the difference? Yes, the reaction that getting help by enzyme has much more lower activation energy needed for a reaction to happen, making that reaction much more faster to finish and create products. Okay, so next we're going to talk about the characteristic and how the enzymes work. So how the enzymes work and its characteristic. The first is it is induced fit. Okay, so I'm going to show you an animation and I'll explain it along the way. Okay. Okay, so this is a substrate and activation site. Notice that the activation site is a bit slightly larger than the actual size of the substrate. As you see here, there, you see that? So it does happen. It could be too big, it could be too small, but when the substrate approaching the activation site, that activation site will automatically adjust itself according to the substrate shape, so it will be snug fit. That's why it's called induced fit. Okay, so next is enzyme work very specific. Okay, just like before, I have an animation here to show you guys. Okay, just wait for it to start moving from the start. Okay, so we have a three substrate here. The first substrate seems to be too big for the activation site. The second one, it's too small for the activation site. But the third one, it's snug fit. So what does it mean? That means different reactant need also a specific enzyme for that. So for example, reactant A needed enzyme A to be able to react on each other. However, if the reactant B is given to the enzyme A, nothing will happen. No reaction will happen because they're different and the enzyme work very specific. In this case, it need reactant A. Okay, so next we're going to talk about things that affect enzyme. So the first is the temperature. Every enzyme has an optimum temperature and a critical temperature. What does it mean? Meaning that the optimum temperature is the point where the enzyme is mostly active. It is the state where the enzyme is work to its best, work to its maximum capacity. That is when the temperature reach the optimum temperature for an enzyme. While the critical temperature is where the enzyme become the nature. The nature. That sounds quite odd also. What does the nature mean? The nature is a state where enzyme is deformed and unable to work properly. So yeah, it's basically when the surrounding condition is not perfect for the enzyme, it becomes the nature. Okay, so I have a graph here to show you guys. This is the point for the enzyme to work at its really best, at its maximum, which again, as I said before, it's called the optimum temperature. If the temperature fall below the optimum temperature, the enzyme will not work because it's too cold. However, if the temperature kept rising up, eventually the enzyme will become denatured, severely damaged, and will not work. And that's why when you got fever, you have to cool down your body so it will not get too hot. Because if it gets too hot, your enzyme in your body will not help you fight that fever because it's the nature, because it's too hot. Okay, so next is pH effect on enzyme. pH affects enzyme much in the same way as temperature does. As the pH increases, the enzyme will reach its optimum point and function as fast as it can. However, as the pH continues to rise, the enzyme will be denatured and unable to work. You see, just like the same principle with the temperature. For example, enzymes in the intestine have an optimum pH of 7.5, while those in the stomach have an optimum pH of 2. Okay, the graph is here. If you look closely, it's a bit quite similar with the temperature. Okay, so this is again the optimum pH for an enzyme. If it's fall below the optimum pH, it will not work because it is insufficient for the enzyme. However, if it's kept rising up, it will become denatured. Okay, so next is substrate concentration. The amount of substrate in a reaction will obviously affect the amount of product created. So once all of the product are formed, no matter how long we wait, there won't be any more product. Because there's nothing to work with. So the enzyme will just idle because there's nothing to work on unless you add more substrate, of course. But if we continue to increase the amount of substrate, eventually it'll get to the point where all the enzymes are full and work at maximum capacity. So it's getting overwhelmed by the amounts of substrate. So yeah, it will not increase the productivity rate of the enzyme. Okay, here I have a graph also. As we can see, if we keep increase the substrate concentration, the reaction rate will also keep rising. But when it's reached the optimum point or the maximum amounts of enzyme can handle, nothing will happen. It will not rise again. It will be just flat. Nothing will increase. Okay, so to make you guys more understand about this one, I want you guys to imagine that your body is a car factory. There you go. We have a car factory. And the enzyme in your body is the worker of the car factory. We have a worker. And the spare part is the reactant. We have spare part and a box somehow. And for the product, we can imagine it as a car. We have a car. So if we only have one spare part that is enough to make one car, we'll get one car. But what happens if we kept increase the amounts of car parts? You see, eventually the worker busy, will be very busy and overwhelmed by the amounts of car part because no matter how you do, they have their own maximum capacity. So if you keep increase the amount of car parts on it, so they won't work. They because they're already busy to make that one car. So you'll end up having lots of car spare parts. Okay. So next we're gonna talk about the enzyme name and the location. Okay, I'll show you the list of an enzyme here and its location in our body. Okay, so for the disclaimer, I know there's lots of enzyme in our body. There are approximately around 1,300 more enzyme in our body for different type of reaction. And of course, it will take so long for us if we're going to talk about all of those enzymes in our body. So we're going to funnel it down to the digestive system only enzyme. Okay. So we have the digestive organ here, mouth, stomach, pancreas, and small intestine. Okay, so we're going to start with the mouth first. So in the mouth, there's one enzyme which is salivary amylase. What does salivary amylase do? It breaks down starch into maltose. Okay, so we're going to move on to the next organ. Oh, sorry, that is the location of the mouth. Okay, so we're going to move to the next organ. Okay, so the next organ is stomach and pancreas. So I'm on purpose grouping them all together because their location is quite similar. So to make it more faster for us to talk about this. Okay, so first we're going to go through the stomach first. There are one enzyme in the stomach, which is pepsin. What does pepsin do? It's break down proteins into the peptides. Okay, so that's all for the stomach. And the next is pancreas. In the pancreas, there are three types of enzyme. The first is amylase, which break down starch. The second is trypsin to break down proteins into the peptides. And the third one is lipase, which break down lipids. Okay, and this is the location of stomach and pancreas. And the next is small intestine. There are four enzymes in the small intestine. With the first is maltose, which break maltose into glucose. The next is sucrase, which breaks sucrase into glucose. The third is lactase, which break lactose into glucose. And the last one is peptidase, which break down the peptides into amino acid. Okay, so That's all I can explain to you guys about enzyme. Thank you for watching. Don't forget to like and subscribe to our channel. It'll be very helpful to us. And I'll put the link in the description for the exercise for this topic. You can check your understanding there. It will not take too long. It's all it's all coming from my explanation in this video. Once again, thank you for watching. Thank you for watching. I'm sorry if there are lots of mistakes in my explanation. Stay safe. Wassalamualaikum warahmatullahi wabarakatuh.